Hi, my name is Bahadur Ahmedov. In this video lecture, we are going to talk about the trigonometric ratios of some angle. So let's say we're given a triangle with a right angle, which is equal to 90 degrees. And let's assume that the length of this side of the triangle is equal to the y, the length of this side is equal to the x, and the length of this side of the triangle is equal to the r. We call the longer side of this kind of triangles with 90 degrees as the hypotenuse as well. And if you are given a triangle with a right angle, there is so-called Pythagoras theorem, which is true for them. Which essentially tells you that, hey, if you just sum the squares of the two shortest sides of the triangle, is going to be equal to the square of the longer side. So please note that whenever you add, simply the shortest sides is going to be more than the length of the longer side of the triangle. So let's do an example in order to illustrate what does it mean, the Pythagoras theorem. It essentially tells you that, hey, if you've got the triangle with the right angle, if this side of the triangle is equal to the 3 and this side of the triangle is equal to the 4, if you know this, then the hypotenuse is going to be equal to the square of the 3, the sum of the squares of the 3 and 4. So essentially, r in the square is going to be equal to the 3 in the square plus 4 in the square, which is going to be equal to the 9 plus 16, which is going to be equal to the 25. Then you can find the r by taking the square root from the 25, which is going to be equal to the 5. So this is equal to the 5. So essentially, if you are given the triangle with the right angle, you can figure out the lengths of this kind of triangles. But at the same time, if you know the lengths of the triangle, you can figure out whether the right angle is present in your triangle. So what we would like to do is for such a triangles, we can, it appears, define the so-called trigonometric ratios. So let's say again, you're given the triangle with some angle, let's say alpha, okay? And again, I would like to write down the length of this side as y, this side is going to be equal to the r, and this side is going to be equal to the r. Then the sine of the alpha is going to be equal to the opposite side divided to the hypotenuse. It's going to be y divided to the r. So at the same time, the cosine of this angle, cosine of this angle is going to be equal to the adjacent side divided to the r. Okay. So one way to memorize what is the size, what is the sine is going to be written down like, hey, you need to divide the opposite to the hypotenuse, and in order to find the cosine, you need to divide adjacent to the hypotenuse. So sometimes we can abbreviate the sine as the COH. Essentially, the sine is opposite to the hypotenuse, So by taking out like the first letters of the three words, right? COH. Well, sometimes we can write down that the cosine is CAH or CAH. It's going to be like a cosine stands for the is the adjacent to the hypotenuse. And again, we can take the first letters of the three words. It's going to be CAH. So just abbreviating the sine as the SOH or the cosine as a CAH just helps you to evaluate this kind of trigonometric ratios whenever you are given the triangles. So let's say we're given a simple triangle. So let's say we're given a triangle. So let's do an example of calculating this kind of trigonometric ratios. Example. So we've learned about the angles already in the previous lectures, right? So let's say you are given the triangle where this side of the triangle is equal to the 30 degrees, okay? And the length of this side of the triangle is going to be equal to the 4, and the length of this side of the triangle is equal to the 8, for example, okay? So now what I want is I would like to figure out what is the sine of the 30 degrees, And at the same time, let's say I would like to figure out what is the cosine of the 30 degrees. Okay, so in order to apply this, I'm going to use first of all the definition of the sine. So if you remember, the sine can be abbreviated as the COH, right? Sine is opposite to the hypotenuse. And the sine of the 30 degrees is going to be equal to the opposite, the length of the opposite side, 4, divided to the 8, which is going to be equal to the 1 over 2. Okay, at the same time, if I would like to figure out what is the cosine, I need to know the length of this side, right? So let's say this is going to be equal to x. I can find the x from the so-called Pythagoras theorem, right? So which tells you that, hey, the sum of the squares of the shortest sides is equal to the square of the longer side. Then I can find the x in the square, which is going to be equal to the 64 minus 16, which is going to be equal to the 48, right? And then the x is going to be equal to square root of 48. So please note that I can take out, probably I can write this down as a 16 times to the 3, right? 16 times to the 3. Then it can be written as, like x can be written as 4 times to the square root of 3. Okay? Then I can find the evaluate cosine of this angle. Cosine. So please note that the cosine terms can be abbreviated as a SOH or CAH. Like a cosine is adjacent to the hypotenuse, then the cosine of this angle of the 30 degrees here is going to be equal to the x divided to the 8, which is going to be 4 times to the square root of 3 divided to the 8. We can just cancel out the things so we can get square root of 3 over 2. So this is how we can evaluate the sine and the cosine if you are given the triangle. So the problem is, so you probably have seen the values of the cosine and the sine for the huge angles. So for example, we know that the sum of the two, so sum of the three angles, so let's say this is beta, and this is the gamma, let's say. So the alpha, and this is the alpha. So for any triangle, alpha plus beta plus gamma is equal to the 180 degrees, right? So if the gamma is equal to the 90 degrees, then alpha plus beta should be equal to the 90 degrees, right? So if essentially if alpha here is given 30 degrees, then beta is going to be equal to the 60 degrees because we are given the right angle triangle. The thing is, sometimes we can see that the cosine of the 2 pi, for example, which is like cosine of the 360 degrees, or we can see that the sine can be evaluated at the 720 degrees, and so on. So how it is possible to calculate the sine and the cosine for such a big angles, right? So obviously it is not possible to do this on this kind of triangles, right? So in our next lectures, we're going to define the sine and the cosine for the longer angles, for the bigger angles, more than 90 degrees.